So now what is black body radiation? So when a body is heated, it emits radiations of different wavelength and frequencies. So this is wavelength. So now the radiations emitted, here the radiations they are emitted goes from lower frequency to higher frequency. So whenever the radiations are emitted, the frequency always, what will be the frequency of those radiations? First the lower frequency radiations are emitted, and then later on it enters into higher frequency radiations. So now the next is, so this body, in order to maintain thermal stability, or you can say thermal equilibrium, so here they are emitting. So in order to maintain equilibrium, they need to even absorb the radiations. So this black body or the body which is heated, they absorb radiations at same rate as they emits them. Alright. So in order to maintain thermal equilibrium, the body which is heated will absorb radiations at same rate as it emits them. So now the body which emits or absorbs radiations of all frequencies is called black body, and the radiation that is emitted by the body is called black body radiation. So now let us see Planck's quantum theory. So as we have seen in black body radiation, when the body is heated, it emits radiations. So here the first point we will be writing is, when black body is heated, it emits radiations of different wavelength or frequency. So these radiations, why are they emitted? They are emitted because of the vibrations that were taking place in the charged particles present inside the body. So the second point will be, the radiations emitted is due to the vibrations taking place inside the body because of the charged particles. So what are the charged particles here? There are only two charged particles. They are protons as well as electrons. So the charged particles are electrons and protons. because of the vibration seen in them, we can see the emission of radiations from this black body. So now how are these radiations emitted? They are emitted in discontinuous manner, not continuously, in discontinuous manner. In the form of, in which form? In which form they are emitted? They are emitted in the form of small, discrete packets called quanta. Small discrete packets called quanta. And these waves, these radiations, they are propagated in the form of waves. They are propagated in the form of waves. And then, now let us discuss about the energy that is associated with these radiations. The energy associated. So how are these energy, how are they emitted, these radiations? They are emitted in the form of quanta. So the energy associated with the quanta is directly proportional to frequency of radiation. So frequency is denoted by nu. Here energy can be denoted by E. So E is directly proportional to nu. In order to remove this proportionality symbol, we will be introducing a constant h, which is Planck's constant, E equals to h nu again. So here E is energy and nu is the frequency of radiation. Now what is h? H is again Planck's constant. Planck's constant. So what is the value for this Planck's constant? It is 6.625 into 10 power minus 34 joules second. Now this joule second we can even write as kg meter square per second. Another one is 6.625 into 10 power minus 27 erg second. So how can we convert this joule into ergs? So there is again one conversion, that is 1 erg is equal to 10 power minus 7 joules. So here in what is 1 joule here again? 1 joule is equal to 10 power 7 ergs. So when we substitute 10 power 7 ergs here, what we will be getting? Which is 6.625 into 10 power minus 34 into 10 power 7 erg second again. This is joules erg second. So what we will be getting? 10 power minus 34 and 10 power 7. So when we will be deducting 7 from 34, so we will get 6.625 to 10 power minus 27 erg second. So in this way we will be converting joules to ergs. So this is Planck's quantum theory as well as black body radiation. And yeah, here this is not by, okay, this is joule second can also be written as kg meter square per second, which is equal to, I will write it again, 6.625 into 10 power minus 34 kg meter square per second. Yeah, one more point for this is energy. So here energy associated is h nu, and a body can emit, this body, black body, it can emit or absorb energy in multiples of h nu. So how can we write that? Black body can emit or absorb energy in multiples of h nu. Multiples of h nu in the sense we can write it in the form of E equals to n h nu, where again n is quantum number which is equal to 1, 2, 3 and so on. So this is Planck's quantum theory.